Hi everyone. So today we'll be studying about the change of base of logarithms. So in our previous lectures we had just studied about the bases of 10 and about any other base other than 10. So today we'll be learning about change of base of the logarithms. Sometimes there are questions asked where you are just asked to change the base of the logarithms, or sometimes a question needs you to change the base of logarithms. Okay, sometimes there's an equation and the bases of the logarithms are not same, so you have to change the base of the logarithm to make them equal. Okay, so I'll just explain it and it will be clear to you once we are done with the example. So let's say that suppose we'll just take an example. Suppose we have a log as log of a to the base of b. Okay, now you are asked that you have to change this log to base c. Okay, you have to change this log to base c. So what will be your answer? The definition for this is, if you have a log which is of a certain base, log of a to the base b, and you have to change it to base c. So the procedure for doing this is like log of a to the base c upon log of b to the base c. Okay, so this is a standard procedure for changing the base of a log. Okay, suppose you have log of 3 to the base 4 and you have to change it to base 6. Okay, this is one example where you are given with the log of 3 to the base 4 and you have to change it to base 6. So how we'll do it? The standard procedure is we'll just take the argument of this log. Okay, so argument of this log is 3 and we'll just write 6 as base. Whatever base that you have to change to, you can write it as base upon log of, you'll just take the earlier base. What is the earlier base? And you will make the argument of that. So log of 4 and the base is 6. Okay, suppose let's take one more example. You have to change log of 15 to the base of 2. You have to change it to base 8. Okay, so it will be log of 15 to the base of 8. We'll first take the argument and we'll attach base with it upon log of, then we'll take the base, the previous base, log of 2 to the base of 8. So here you are changing the logs to the same base. Okay, so we'll just do one more example so it is clear for you. Now, this is your question. You have to change log 7 to the base of 2 to base 10 and hence evaluate log 7 to the base of 2 correct to 3 significant figures. Okay, so what is the question? We have to change log of 7 to the base 2 to base 10. Okay, so what we'll do, we'll first take the log of the argument, log of 7. What base has to be changed here? 10. We'll take the base as 10 upon log of, what is the previous base? What was the earlier base? So it is 2. So log of 2 to the base 10. Okay, so what it will become? It will become log 7 upon log 2. So you can find it from your calculators, the value of log 7 upon log 2. So it will be 2.81. It will approximately be equal to 2.81. So we have written 2.81 here because you have to give your answers correct up to 3 significant figures. Okay, so this is how you change the base of the logarithms. So we'll do one more question so it is easy for you to understand. Okay, so now here we have to find the value of x. We have to solve for x. Okay, solve log of x to the base 3 is equals to log of x plus 6 to the base 9. Now earlier, when the bases are same, you can simply just equate the arguments and find the solution. But here the bases are not same. So first we have to make the bases same. So how we'll make the bases same? What we'll do? We'll just log of x to the base 3. So let's make everything to the base of 3. Okay, so now you have to convert this to base of 3. So what will be our answer? It will be log of argument. What is the argument? X plus 6 to the base, whatever we have to change the base to, 3, upon log of, what was the previous base? 9, and what we have to change to, the base, what we have to change to, it is 3. Okay, so log of x plus 3, x plus 6 to the base of 3 upon log of 9 to the base of 3. Okay, now we'll write it as log of x to the base 3 is equals to log of x plus 6 to the base 3 upon, now this value will be equal to 2. Okay, now just tell me and write it in the comment section why this is equals to 2. Okay, So this value is equal to 2. We have learned in the previous section, in the previous lectures. So you just explain in the comment section why this value is equals to 2 and how this value is equals to 2. Okay. So now we'll cross multiply. Cross multiply. 2 into log of x to the base 3 is equals to log of x plus 6 to the base 3. Okay. So now by power rule, we can shift this 2 to the exponent of x. So this will be log of x squared to the base 3 is equals to log of x plus 6 to the base 3. Okay. Now the bases are same. So we can just equate the arguments. So it will be x squared is equals to x plus 6. So now when you will shift the right hand side, the terms of the in the right hand side to the left hand side, it will become x squared minus x minus 6 is equals to 0. Okay, so this is your quadratic equation. This is your quadratic equation. You can factorize to solve for the value of x. Okay, so what will be the factors? Your factors will be x minus 3 into x plus 2 is equals to 0. Now we'll just check for the values of x for which this solution is valid. Okay, so first we'll take when x minus 3 is equals to 0. Therefore, when x is equals to 3. So what will be the value of this expression when x is equals to 3? Okay, we'll just check. So for this, we'll be like log of 3 to the base 3 is 1 and log of 3 plus 6 is 9. 9 to the base of 9 is also 1. So your x is equals to 3 is a valid solution for this. Okay. Now we'll check for x is equals to minus 2. Okay. We'll check for x is equals to minus 2. Minus 2. So log of minus 2 to the base 3. Now this log is not defined. Why? Because log of any negative number is not defined. Log of any negative number is not defined. So x is equals to minus 2 is not a valid solution. X is equals to minus 2 is not a valid solution. Okay, so it is not a valid solution. So what is the solution for this? So the value of x is equals to 3. So we have just solved for the value of x. Now there was one equation. The bases of that equation on both the sides were not same. So first we just changed the base to this. We just changed the logs to the same base and then we solved it for the value of x.